This video is about variables and goes with 6th grade CPM, Chapter 4, Section 1, Lesson 1. First, let's define variable. A variable is a letter used to represent an unknown value. This can also be a symbol, but right now we're just using letters. In the past, you may have worked on a problem similar to this one, where you have the sum of 5 and x is 15. In this case, the variable is x, and you're able to quickly figure out that the value of the variable is 10, and we would write that as x is 10. We're going to start by looking at two distances that are equivalent, and that's what these red lines here represent, is that this up top is the same distance as down at the bottom. And if we look at this problem, are we able to solve for variable z? The answer is yes, and I want you to take a moment to pause the video and see if you can work through it on your own, and then I'll show you two ways that I could solve this on my own. What's probably the easiest way to solve this problem is to look at these and say, I know I have a z value up here, so I'm going to get rid of that one and get rid of its equivalent z value on the bottom. I'm going to do that as many times as I can, which gives me 3. And then what that leaves me with is this section here. And then what I'm able to do is I'm able to say z and 6 is the same as 9. And once we've done that, we're back at the same sort of problem that we solved before, where we can do it quickly in our head and see that z is equal to 3. And then we can say 3 plus 6 gives you 9. Another way you can look at this is setting it up as two equivalent expressions. And you're going to get into this one a lot more as you get into more advanced concepts. And the idea is to get your variables completely by itself. And the way that I would do that is I would subtract 6 from this side. And in order for that to work, I also need to subtract 6 from this side. Okay? And then what that would give me is a new set of z's. And I wrote that here, and I simplified it a little bit, and I counted my z's, and so that I have 4 z's on the left side of my equation, and I have 3 z's on the right. And I took the 6 away here, so that goes away, and I took 6 from here, which is where I get that 3 from. But again, I want to separate this from the variable from everything else. So I need to take my 3 z's away here, so I can get rid of that section altogether. And I'm going to subtract 3 z's over here, which leaves me with 1 z, which is the same as 3, which is another way that we're able to work through this problem. Try using that same equivalent expression method to solve this problem. 5 plus y plus y plus y is the same as 17. Remember, you want to get y completely by itself and see how you can do that. The first thing that I did is I took 5 away from this side, which gets rid of that 5 altogether, and I subtract 5 on that side. Then I simplify so that I have 3y equals 12, and I can want to figure out what y itself is. So I'm going to divide this side by 3 to get rid of my 3, divide that side by 3, and then I know that y is 12 divided by 3, which gives me 4. So then I can see that y is 4. Okay, and then quickly check your work. 5 plus 3 times y is 17. 5 plus 3 times 4 is 17. 5 plus 12 is 17. And 5 plus 12 is 17, which gives us 17. And notice I have that upside down triangle that we've talked about in class. And there you go.